Okay, so these are the examples that I left you with, and I encourage you to try them because in mathematics and computer science and anything like that, the best way to learn is by doing. Me talking to you doesn't actually teach you these things. You have to actually try to do them yourself. So I strongly encourage you to try to do these, and we will work on these in this videos, and then we'll go on to the next one. So we're going to do 26, we're going to do 12, we're going to do 1, 1, 0, 1, 0, 1, and we're going to do 0, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1. Those are the ones we're going to work on. And they're too high for you to see, but that's okay. We'll get them. So, first, 26 base 10 is equal to what base 2? How would you actually even do this? Well, you can try to guess what numbers would fit into this, what base 2 numbers fit into this base 10 number, and then try to work it out. Later after these examples, I'll teach you a process that is easy and works every time, but it's good to sort of work your intuition first. So 26, we need powers of 2 to come out of this. When we're doing this in base 10, we use powers of 10. There's a 2 10s and 6 1s, but now we're going to do this in base 2, so we need powers of 2. Well, what are some of our powers of 2? Well, we've got 1 is a power of 2, and 2, and 4, and 8, and 16, and 32, and 64, and on like that. So what is the biggest power of 2 that will fit into 26? Well, it's 16. So this is 16 plus 10. All right, well, 10 isn't a power of 2, but 10 is 8 and 2. So this is 16 plus 8 plus 2, or 2 to the 4 plus 2 to the 3 plus 2 to the 1, or 1, 1, 0, 1, 0. And that's it. That's the process. So this is the list of powers of 2, and we just figure out which powers of 2 we need to put together to get this number, and then we're going to get the binary code for that integer. That's really all it takes. You just have your palette of powers of 2, and you can build up any number using some combination of these powers of 2. And because these are all logarithmically arranged, you can build any number from a combination of single instances of each of these numbers. That's the beauty of base 2 system, is that you can build any number using these numbers. So that's the first one. That's 26. That's good. What about 12? Well, if we start with these same numbers, 1, 2, 4, 8, 16, 32. If we start with these same numbers, which numbers do we need to get to 12? Well, 16 is too big, so we'll have 8 as the first one. And then, what's left? 4. So if we add 8 and 4, then we're done. 12 is 8 plus 4. So 8 is 2 to the 3, 4 is 2 to the 2, so this is 1, 1, 0, 0. You need those zeros as placeholders to indicate that this is actually 2 to the 2 instead of 2 to the 0. So this is 12, 1, 1, 0, 0. And that's our answer. Good. All right, now we'll go the other direction. We're going to do 1, 1, 0, 1, 0, 1 base 2 is what in base 10? Well, going this direction, this is actually a little bit easier because we don't have to divide. We don't have to guess which numbers are going to fit. All we have to do is just add these numbers up and see what the result is. So the first thing we have to do is figure out what each of these ones represents. And you can do that by looking at their place value. So this is 2 to the 0. That would be 2 to the 1, but we don't have any. This is 2 to the 2. This would be 2 to the 3. This is 2 to the 4, and 2 to the 5. So these are the numbers that those represent. 2 to the 5 is 32. 2 to the 4 is 16. 2 to the 2 is 4. 2 to the 0 is 1. You're going to really want to practice your powers of 2 because these things are going to be very useful later on when we're doing this kind of work. And we just add these up. 16 and 4 is 20. 20 and 32 is 52 plus 1. 32 plus 20 plus 1. 52 plus 1. 53 is our value. Okay? Now we get to the big long binary one, which we'll see what its value is. 0, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1. just like before, all we have to do is take each bit in turn, figure out what its power represents, what its place value represents, and then add them all up. So this is 2 to the 0, 2 to the 1, but there isn't any, 2 to the 2, 2 to the 3, there's no 2 to the 4, 2 to the 5, no 2 to the 6, 2 to the 7, 2 to the 8, no 2 to the 9, no 2 to the 10. And in fact, you could have zeros forever. Just like in a regular base 10 number, you can add zeros to the front of it without changing its value. So this is the value that these binary numbers represent. Now we've got to figure out what these powers are. 2 to the 0 is 1, 2 to the 2 is 4, 8, 2 to the 5 is 32, 2 to the 7 is 128, and 2 to the 8 is 256. We add all those up and we get the number that this corresponds to. Well, 32 and 8 is 40, and 128 and 256 is a big number, and that's more big numbers, and we can calculate that out. I could run that in my calculator, but I'll leave that as an exercise for you. So this is the process that we can use to get from binary to decimal. Wouldn't it be nice if we had an actual process to get from decimal to binary? In the next video, I'll show you what that process is.